Hello guys, can you hear me? Let's see. Okay, I should increase my sound. Now you should be able to hear me well, I guess.
Attention all.
How was today's contest, guys? How many problems you solved today? It was great. Nice. Let me bring the chat. 2. Stuck on C. This round felt like Speed Forces. C was Demon. 0, I did not attend. My first one. This is your first round in Codeforces? Come on. That's nice. I mean, if this is your first round, that's nice. I remember my first round, it was 10 years ago. It was really nice. I mean, I remember that I was in a school. We were in a school in our first round, all of us. And I solved one problem and I became so happy because no one else solved any problems. I completely remember that day. I solved only one problem A, and it felt really awesome because no one else in our class solved any problem then. Okay, I see. Do you have video on divide and conquer? Not yet, but in our topic stream we can discuss divide and conquer in our next topic stream. Let me resend the link to Telegram. I think most of you are in our Telegram channel right now, but still I will send you the link again if you want to join. I'm sending it each time in the topic streams. If you want, you can join our Telegram channel and also our Telegram group. You can find the link of the Telegram group as well in our Telegram channel. And then in there we're gonna have votes and for our topic streams, which topic you want me to cover in our topic streams. I saw comments on how can I get a Codeforces t-shirt. You should win it. I do not think you can buy it. I think you should win in a round. Are you Indian? I'm not. Can you guess where I'm from? Everyone know right now. So okay, so shall we start talking about the problems? I don't wanna keep you waited so much. Yeah, I'm from Iran. Hey, Junadra. No, not Morocco. Okay. So I know that many of you guys are waiting for the discussion to be started. So let's just send the code from Hanoi, Shayan. What do you mean? I didn't completely understand. Okay. So let's start talking about the problems. By the way, the color of this day, the color of light is blue. If you want me to change it, you can tell me to change it. But for now, it shows blue. So let's start talking about problem A. Greedy monocarp. Okay. Greedy monocarp states that there are n chests. The ith chest initially contains a sub I coins. For each chest, you can choose any non-negative 0 or greater number of coins to add to the chest. With one constraint, the total number of coins in all chests must become at least k. After you finished adding coins to the chest, greedy monocarp comes who wants the coins. He will take the chests one by one, and since he's greedy, he will always choose the chest with the maximum number of coins. Monocarp will stop as soon as the total number of coins he takes is at least k. You want Monocarp to take as few coins as possible. So you have to add coins to the chest in a way that when Monocarp starts taking chests, he will take exactly k coins. Calculate the minimum number of coins you have to add. So you're gonna add coins to the chests, and Monocarp, after that, Monocarp starts to take coins from the chest. He will start from the greatest one. You want to make sure that he will stop when he gets at least k. You want to make sure that at that time he will get exactly k coins. Well, the point is that if you start from the beginning and move forward, you know that, I mean, if you sort them, you sort all the elements, you know that Monocarp starts from the first one and goes as long as the number of coins in his hand is less than k. He will continue. He will stop when it's going to be greater than or equal to k. So let's consider the last step consider the last step. Assume that for now, assume that we're not adding any coins. For now, assume that we're not adding any coins. Consider the the last place that the number of coins till there is at most k. And you know that if you add just one more coin, if he takes just the next coin as well, then it's going to become more than k. So the point is that definitely we should not let Monocarp to take this one. The next one. So definitely everything must be finished here. So if you consider the sum of all the coins so far till here, if it is s, we know that s, it is less than or equal to k, but if you add the next coin to it, it would be greater than k. So the point is that I argue that the answer is gonna be k minus this s. Why? Because if you just add k minus s to the first coin, the order will not change. If you add this much to the greatest coin, the order will not change, definitely. And if you start from the beginning, you will still stop here, and in here you're sure that you have exactly k coins. This way, instead of s coins, because you have added k minus s to it, you're gonna have exactly k coins. And this is the minimum you should add, because you are sure that you should not use the next coin, because if you take the next coin, it definitely is going to be greater than k. So you know that you should not take the next coin, so you should somehow use these coins and achieve k with these coins. So k minus s is the least that you need to add, because you need to just consider these coins and try to reach k with these coins. So k minus s is the least that you should add. So the answer is going to be, you consider the smallest prefix such that its sum is less than, or the greatest prefix such that its sum is less than or equal to k. If its sum is s, your answer is going to be k minus s. If I want to draw you on an example, for example, consider the second example, 4, 1, 2, 3, 2. We first sort them, because you know that Monocarp starts from the biggest sum. We sort them in decreasing order, in descending order. So it's going to be 4, 3, 2, 2, 1, this second test case. So when Monocarp starts, we know that our k is 10. So he will take this one, the sum is going to be 4, then it's going to be 7, then 9, then 11. So this is the last place that our sum is less than 10. And if we add less than or equal to 10, and if we add the next one, it's going to be greater than 10. And what is our sum so far? Our sum so far is 9. So our answer is going to be 10, which is our k, minus 9, which is our s. So our answer is 1. And you see that our answer is really 1 in here. Does it make sense? Is it clear? If it is clear for you guys, please put a plus or use this emoji. If you have any further questions, you can also ask me if you have any other questions about this problem. Otherwise, we can move on to problem B now. Come on, C, please. Okay, we get there. We get there. Sure. ICBC t-shirt looking cool. Yeah. I exchanged it with another team. It was Moscow team. Our team had another t-shirt. I changed one of my t-shirts. Like after football, how players exchange t-shirts. We also exchange our t-shirts after the round. So this is a Moscow team. They're from Russia. They're from Moscow. This is their t-shirt. Okay. You played in Jakarta? No, I haven't. Yeah, Ronaldo. Yeah. Okay, so I don't remember the name of the university. It must be written on my back, but I haven't. I forgot it. I read it and tell you. I commented. Okay, so let's not talk about the next problem. Problem B. dry run on the last test case. On the last test case is 3, 3, 8. So if you sort them, 3, 8 and 3, 3, 3, if you sort them, it's going to be 3, 3, 3. When you get the first two, the sum is going to be 6. If you add the next one, the sum is going to be 9, more than 8. So you will stop here. So your S is 6, your K is 8. So your answer is K minus 8, K minus S, which is 8 minus 6, which is 2. So on last test case is 2. Okay. And again, guys, how many of you attend our topic streams? We're gonna have topic streams most probably on Wednesday. So whatever topic you want me to discuss, I'm gonna put the poll probably today after the round. You can join our Telegram channel and I will put the vote there. I will discuss the topic that you want me to discuss. So, and I would love to see you guys on the topic streams as well. So if you want, you can join there and attend the topic stream, and we will decide that binary search can be an option. Yeah, we can talk about binary search. I put that in the votes for sure. Maybe I can put a message there right now. I'll put a message right now there. So let me, for a second, sorry for keeping you waited. What topic do you want me to discuss in the next topic stream? Okay. So let's now talk about the let's talk about the next problem now. So problem B. So let me bring it for a second. Okay, so problem B. Game with colored marbles. Alice and Bob play a game. There are n marbles. The ith of them has color CI. The players take turns. Alice goes first, then Bob, then Alice again, then Bob again, and so on. During their turn, a player must take one of the remaining marbles and remove it from the game. If there are no marbles left, all n marbles have been taken, the game ends. Alice's score at the end of the game is calculated as follows. She receives 1 point for every color X, such that she has taken at least one marble of that color. Additionally, she will receive 1 point for every color X, such that she has taken all marbles of that color. Of course, only colors present in the game are considered. For example, this is an example. If, for example, Alice first takes the first marble, then Bob takes the third marble, and so on. In this test case that they're talking about, Alice gets 4 points because in this test case, if you look at it, Alice will take colors 1, 3, and 4, one of them from 1, 3, and 4. And since she gets all the 4s, we have 1, 4, and she takes that, she will get 1 additional point for that as well. So the answer is going to be 4. Alice wants to maximize her score at the end of the game. Bob wants to minimize it. Both players play optimally. So you have to say that what the score of Alice is going to be at the end if they both play optimally. So, well, first of all, let's talk a little bit about their strategy, how their strategy must be. So, what I say first of all is this. I mean, there are some marbles that we have only one of them. So we have some marbles, we have some colors. We have some colors for the marbles that we have only one of them. So some colors with one marble, and some colors. This is C. Some colors. And some colors that we have more than one. First of all, I say that the ones that we have only one of them have the priority, because if we take them first, we get 2 score instantly. We get that a marble from that color, and also we get all of the marbles from that color. So if we can take them, it's good to take them instantly, because there's no other move that gives us more advantage. Instead of every other move, we can just try to first take this one, this marble. And also for Bob, it has priority as well, because by taking one of these, it can stop he can stop Alice to take that marble, the marble from that color. So the point is that as long as we have some color with exactly one marble of that color, we will take that. We will take that marble. But if we will continue doing this, after a while, all of them are used, and all of the remaining marbles are gonna have at least 2 occurrences. So we're gonna have at least 2 marbles of each other color. Okay. So the point is that I show you that once we get, so I proved a fact first. I talked about fact first. Our observation was that as long as we have a color with only one marble having that color, with only one marble, I write in shorts, then that one has the priority. We will take that one, we take that one, we take that one. Any of the players that it's their turn will take that one. We will stop when all of the marbles have at least 2. All of the colors have at least 2 marbles. In that time, I show you that if we have C different or K different colors, I show you that the score of Alice from there is gonna be K, exactly K. Because I show you that on one hand, the result of Alice there is gonna be at least K. On the other hand, I will show you that it's gonna be at most K. So I assume that I have K different colors, and I have 2 from each one of them. I'm also considering that I have 2 from each one of these colors. I want to prove that the score that Alice will get from them is exactly K. How do I show that it is exactly K? First I say that it is at least K. Why? Regardless of whose turn it is. Even if Bob starts or if Alice starts, in both cases, the score of Alice is going to be at least K. Why? Because I can say that, each time I know that Bob can choose one of the marbles. Whenever he chose a marble of some color, instantly after that I choose the other marble of that color. I know that from each color I have at least 2 of them. So whenever Bob chose a marble of some color, I choose the other one. So I'm sure that I won't miss that. So what I'm proving is that I will never miss any color. Because Bob can never instantly remove all the marbles of some color. There's some time that he will take one of them, and just instantly after that I will take the other one. So I will never feel danger. That's what I'm saying. I will never feel endangered that Bob can take all of the marbles of some color. Whenever he took one of the marbles of some color, I take the other one. So this way I make sure that my score is going to be at least K. Also, I can ensure that, Bob can ensure that the score of Alice will be at most K. How? It's only enough if he ensures that Alice will never take all of the marbles of some color. It's only enough to say that Bob can ensure that Alice will never take all of them. So Bob also can say that I can take one from each color as well. How Bob can say that? Bob can also do the exact same thing. Bob can assure that Alice cannot take all the marbles of some color instantly. Whenever Alice took one marble of some color, Bob takes another one. So also Bob never feels in danger that I will lose some color. He can just, if some color was in danger, for example, Alice has took one of them and only one is left, he will take the other one. So the point is that both of them can be sure that they can take at least one marble of each color. So at this point, the answer is going to be K. So the point is that first I see that how many marbles do I have with only one occurrences of them. For example, if there is some X, there are X marbles with only one occurrences of them. I say that the sailing of X over 2 will go to Alice and the floor of X over 2 will go to Bob. And then if I had, for example, K marbles, or let's say because I used X here, let's use Y here. If there were Y marbles with more than one occurrences, with more Y colors with more than one marbles, From them, Alice will take y. The score of from each one, she will get 1, but she will not get also. Her score at the end is going to be 2 times sailing of x over 2, because she will take all of the marbles of these colors, because there's only one of them. The score for her is going to be 2 plus y. For each of these y ones, she will take 1. So it's going to be her final score. Do you guys agree with this? So, and also tell me if your solution is also the same, because I didn't participate in the contest, and this is just the solution that I had in my mind when I read the problem. So also let me know that if you have used also the same solution. Why multiply by 2? Well, the reason is that we multiply it by 2 because for each one of them, for each one of these marbles, we take all of the marbles of that. So we get one score for taking one, and one score for taking all of them, because there's only one. So when we take only that one, we have took all of them. So that's why we multiplied by 2. From those colors, our score is going to be 2. Okay, use the same solution. Good, nice. Thank you, Rafi and Sankar and Junaid. Why n is 1,000? Well, usually in the first problems, the constraints are on n are lower. I mean, in Codeforces. So, but there are also, yeah, I agree that in this case it doesn't make it easier. It's more confuses the contestants. So, yeah, it rather confuses. Where are you from? Nima has asked. I guess that's from the same place that you are from. Isn't that true? I guess that you are also from Iran, based on your name. I'm from Iran. Yeah, based on your name. Right now I'm living in the US, but I am originally from Iran. Yeah. So, if you want, I can also dry run. While you don't participate in contests, I really don't have time, unfortunately. I have a lot of things to do. And for example, right now, I just most of them quickly have to read the problems and come up with the solutions. And some of the solutions will be left that in the solution discussion, we will go over them. So, it's unfortunately a lot of work. It's so sad. Anyway, for dry run, for example, in this case, x is 2 because we have 2 colors with more than 1 marbles and 1 color with 1 marble. So the answer is going to be 2 times sailing of x over 2. It's 1. So it's 2 times 1. Plus, there are 2 marbles. Y is 2. So it's going to be 2 plus 2, which is 4. In this one, x is 3. Y is 0. So we have 2 times sailing of x over 2, which is 2 plus 0. So 2 times 2 plus 0, it is 4. In this one, x is 0, y is 1. We have 1 color with more than 1 marble, so the answer is 1. 2 times sailing of x over 2 plus y is going to be 1 in this one. So this is also dry run on the samples. Okay. Shall we move on to problem C? Yes, C also seems to have a good solution, as I see. I think it's beautiful. If you guys understood the solution, please use this 100 emoji or put a plus in the chats so that we can move on to problem C. I will talk about C just right now, after I make sure that you're okay with B. Okay, so it seems like you guys are okay with that. Nice. Nice. And guys, also do not forget to put the topics that you want in the Telegram channel. Reply that message. I put the vote after the stream today to find out that what you want the stream topic to be, and then we're gonna have it on our Wednesday morning. It's gonna be your Wednesday's evening. Okay, so let's move on to problem C then. Problem C. Competitive fishing. It says that Alice and Bob participate in a fishing contest. In total, they caught n fishes, numbered from 1 to n. The bigger the fish, the greater its index. Some of these fishes were caught by Alice, others by Bob. So, their performance will be evaluated as follows. First, an integer m will be chosen and all fish will be split into m non-empty groups. The first group. The point is that we split them into m groups. The first group, which is a prefix of all of them, gets a score of 0. The second group gets a score of 1. The third group gets a score of 2, and so on. The last group gets a score of m minus 1. And then the score of each player is gonna be the sum of the scores of the fish that they have taken. And then it says that you want to assign these values to these fishes, or to this fish, because the plural form of fish is also fish. So you want to assign the values to fish so that at the end the score of Bob should exceed the score of Alice by at least k. What is the minimum number of groups that you have to split the fishes into? Okay, so let's talk about it here. So, let's take a look at it. We know that, we are given the fishes in the sources order. We have them as a binary string here. And we know that each one of them is taken by Alice or Bob. For Alice, it's 0, and for Bob, it's 1. If Bob has taken them, it's 1. And we know that at the end, we want to split them into several groups like this. These ones get the score of 0. These ones get the score of 1. This gets a score of 2. This gets a score of 3. And in each one of them, it's like we calculate the number of 1s minus the number of 0s and multiply them by this value of that group. In this one, also number of 1s minus the number of 0s, and we multiply it by 2 here. In here, we have the number of 1s minus the number of 0s and multiply it by 3. And in the first one, number of 1s minus the number of 0s multiplied by 0. So this is the sum of the values that we have. Well, my idea was that we can look at it like this. Instead of calculating this value by 1, and this by 2, and this by 3, let's first calculate the sum of all these values. So I'm saying that calculate in this suffix what is the number of 1s minus the number of 0s. And then calculate it in this suffix, that's what is the number of 1s minus the number of 0s. And then calculate it in this suffix, what is the number of 1s minus the number of 0s. Do you agree that it is going to be the same? Because every 1 in here will be counted exactly 3 times. Every 0 will also be calculated 3 times. In here, every 1 and every 0 will be calculated 2 times. In here, every 0 and every 1 will be calculated once. So I'm saying that instead of just calculating the difference of 1s and 0s in here and multiply by 1, in here and multiply by 2, and in here by multiply by 3, let's calculate it, the number of 1s minus 0s, the difference, in this suffix. By suffix, I mean several elements from the end, in the end of the array. Let's calculate the sum of 1s minus 0s in the end and multiply them by 1 only. Do not multiply them by any number greater than 1. And then sum it up with this suffix, the number of 1s minus the number of 0s in this suffix. And then sum that up with the number of 1s minus the number of 0s in this suffix. Okay, so this is basically what I'm doing. Instead of looking at it like that I will multiply this part by 1, this part by 2, and this part by 3, I say that I multiply this suffix and add this suffix and this suffix. This way, automatically, everything in here will be counted with the coefficient of 3, everything in here will be counted with the coefficient of 2, and everything in here will be counted with the coefficient of 1. Is it clear? Is the general idea clear? That's what I want to do. I mean, this is the main idea of the problem, actually. So basically, I'm saying that I'm trying to see, instead of multiplying this by 1, this by 2, and this by 3, I calculate this suffix, the number of 1s minus the number of 0s in this suffix. And then I will calculate the number of 1s minus the number of 0s in here, and then calculate the number of 1s minus the number of 0s in here, and add them up. The value is going to be the same, exactly. The value is going to be exactly the same. If you understood that, what does it mean? Please use this 100 emoji or put a plus in the chat if it is clear. Otherwise, if it is not clear, if you had any question about it, ask it from me. You're asking because we really apply binary search. I do not apply binary search. My idea is not using binary search. I missed one of your comments. When I zoom in, it does not let me to scroll, and it's annoying. But how to get to know how many elements we have to put in? Yeah, that's what we just figure out later. For now, I'm just saying that how can we calculate the scores if we set the groups? So I'm changing my vision of looking at the groups and calculating the values at the end. So I do not want to, for now, I do not want to split them into groups. I want to say that if I have the groups, how can I calculate the score? I'm changing my vision of that. And by doing that, that helps me to now try to maximize this score when I look at it like this. Yeah, so, okay, for some of you it was not clear, so I will explain it very quickly again. So I'm just saying that, how do we calculate the score? How do we calculate our score? For example, assume that I can dry run actually. So yeah, you also suggested to dry run. So I will dry run so that for all of you it would be more clear. So let's assume that let's me myself to generate some example. For example, assume that this is the string that we have, for instance. So assume that, and our groups are like this. Our groups are like this. So the score of everything in here is 1, the score of everything in here is 2, in here, 0, 1, 2, 3. 0, 1, 2, 3. So the number of 1s minus 0s in here is 1. In here is minus 1 because we have 1, 0 and no 1s. And in the last one is 1. So our score is going to be 1 times 1 plus minus 1 times 2 plus 3 times 1 times 3. So it's going to be 1 minus 2 plus 3. It's going to be 2. This is our score, right? So now I want to find, I'm suggesting another way to calculating this score. I'm telling you that instead of this, let me copy this. I'm telling you that instead of doing what you're doing, let's find out that in this suffix, what is the number of 1s minus the number of 0s. In here you have 4 1s and 3 0s. So the number of 1s minus 0s is 1. In this suffix, it's gonna be 0 because we have 2 1s and 2 0s. And in this suffix, it's gonna be 1 again because we have 2 1s and 1 0. So we see that the sum of these numbers is also 2. So it's gonna be the same value as what we saw in here. So I proved that, what I want to show, what I want to prove is that in these two ways, they are going to be the same. Why? What is the reason that they are the same? Because let's take a look at every bit in here. If it is a 1, it contributes to 3 answers. So it really is like multiplied by 3 because it is both. It is calculated in here, and it is calculated in here, and it's calculated in here. So it's calculated in 3 places. So it's like we are really multiplying it by 3. Every bit in here is calculated in 3 places. So it's like we are really multiplying it by 3. Every bit in here is calculated in two places, in here and in here. So it's like we are really multiplying it by 2. And every bit in here is multiplied by 1 because it's calculated in only one place. So basically what I mean is that if you consider, instead of looking at it like this, when you want to calculate the score, let's look at it like how I suggest. Let's, instead of that, consider all the lines between the groups and just sum up the values of these suffixes. If you look at it like this, it would simplify this problem by a lot, because now you're working with suffixes and you know that what are the sum of the suffixes, so you can easily take the largest ones. Is it clear now? If it is clear now, please put a plus or use the 100 emoji. So you're looking to create as many subarrays as possible from the end. Yeah, basically, yeah. I will tell you about the rest very soon. So, but so far, is it clear why these two ways of calculating the score are the same, actually? No, we do not know how to divide our string. That's my point. I have not yet decided how I want to divide my string. I have just told you that if I know the dividing, how do I calculate the score? So I changed the way that I calculate the score, and this gives me a new intuition on how to solve the problem. Okay. So this gives me some intuition about how to solve the problem. Okay, nice, awesome. So now that I know this, as soon as I want to split, now I'm talking about how to split. Now that I know that my score is going to be like this, the sum of these suffixes. As soon as I want to have m groups, m different groups. So it means that I have m minus 1 of these lines between the groups. So it's like I can just consider the m minus 1 largest suffixes, m minus 1 suffixes with the maximum sum, So it's like, let's calculate all the suffix sums. Very similar to prefix sums. Let's calculate all the suffix sums. Start from the end and save that until everywhere what is the sum so far. And then just let's just sort them. Let's sort all the suffixes by their sum. And then when you want to split it into m groups, because we are looking at it like this, we know that our score at the end is going to be the sum of these suffixes. So it's the best to choose m minus 1 suffixes with the maximum sum. So basically, I mean, this is very similar to prefix sum. I again send you the links to my video that I explained prefix sums. If you want, you can watch that. It is completely like prefix sums. It's just we start from the end, we go backwards, and we try to calculate the answers. This is the link to the video of prefix sums. So we use the idea of prefix sum. We start from the end and we calculate the value of each suffix. So I mean that the number of ones minus the number of zeros. We calculate the number of ones minus the number of zeros. It's a very simple DP. Prefix sum is a simple DP. So each time, if you see a 1, you add 1. If you saw a 0, you will subtract 1 from your score till there. And when you want m groups, it's like you have m minus 1 lines. So it's like you choose m minus 1 of the suffixes. It's the best if you choose the ones with the maximum sum. I will also dry run on a test so that you see it and it would further clarify it for you. So this is how we can maximize our score if we're gonna have m groups. We're gonna just take the m minus 1 maximum suffixes. And once you calculate them, it's just enough to find the smallest m that the sum of them is gonna be at least k. So you can each time increase m. I mean, you have all the suffixes in descending order. You have sorted them in descending order. Now you just need to find out that how many of them you should take such that their sum is going to be at least k. Whenever their sum became k, you can stop. I mean, those many are sufficient for you. And you can calculate the answer this way. So, yeah, awesome. Is it clear for you guys? Yeah, it is. it is so cool this way. So it's not this is not a hard problem. That's why I liked this problem actually. If it is clear for you, please again use the 100 emoji, this one, as the other ones are also sending it. And otherwise, let me know. Yeah, okay, I will also show you code as well. Yeah, sure thing. Sure thing. Yeah, sure. Yeah. Yeah, this is a very common technique. This is called, the only name that I can say for it is prefix sums. It's also considered as double counting as well. Let me write it in here. The idea that I looked at the sum in another way is in combinatorics we call it double counting. Let me see if I can find a link to send it for you so that if you want you can read about it. Double counting, it means that we count something in another way instead of how we count it right now. So this is exactly what we did in here. Instead of calculating the answer in some way, we counted it in another way. Yeah, this is a very good link in Wikipedia. So as you can see in here, this technique that I used is called double counting. You can read it in here. In combinatorics, double counting, also called counting in two ways, is a combinatorial proof technique for showing that two expressions are equal by demonstrating that there are two ways of counting the size of one set. So basically, I showed that the sum of these suffixes, is equal to this. I showed that there are two different ways of calculating the same thing. And then I said that, okay, now that there are two different ways of calculating the same thing, instead of maximizing this, I will maximize this, because maximizing this one is way more intuitive. So I know that when I maximize this, that one will maximize as well, because these two are the same value. These two are the same thing. So I look at it like this and I try to maximize this, because this way is more intuitive. So this is also called as double counting. So let me now dry run on a test case. For example, which test case do you think is the best one to dry run? For example, we can, if you want, you can suggest any of them. Otherwise, I can, for example, dry run on the third case that you see in here. Let me write it in here and then I switch on to the tablet. It's 4 1 0 1 1 0. So first of all, I find the sum of all the suffixes. The answer for all the suffixes. The answer till here is -1. The number of zeros minus ones is ones minus zeros is -1. We have one additional 0. Till here it is 0. Till here is 1. In here is -1. And I have to. So these are my answers. I cannot pick the first suffix. So this one is not going to be useful. The first one is not going to be useful because it means that, because we cannot put a border in here. We can never put a border in here. So I'm never going to use this -1. In this case, I'm not even using this anyway, but you just need to take care that you cannot use this suffix. So you have these values basically. Starting from 1, you have 1, 0, and -1. The point is that in here, if you just take this suffix, this is going to be enough for you, because this is going to be a 1 to you. Because if you take this suffix, it means that you have this 1 1 0 and it gives you a 1. So you see that in this test case, it can easily give you the answer. The fifth one. Okay, sure. I will also show you the fifth one is this one. 6 3 6 3 0 0 1 1 1 and 0. So again, in this one, let's first calculate the scores of the suffixes. It's gonna be, this one is gonna be -1, this one is gonna be 0 1 2, and then 1, it decreases again, and then in here 0. We know that I can choose from these ones because I can put the border either here or here or here or here or here. So my values, I sort these suffixes. If I sort them, it's going to be 2 and 1 and 1 and 0 and -1. I start from the beginning. I want the sum to be 3. First, I take these 2. So I put one border in here, sorry, in here, 2 is the next one. In here, it gives me a 2, and then I want a 1, I have a 1, so I put another border either in here or in here, because both of them are 1, there's no difference. For instance, in here. So this way, if you look at it, you should get 3, because you should get 2 plus 1, you should get 3. And let's see if we really get 3. In here we have minus 1 times 1, which is minus 1. In here we have 2 times 2, which is 4. So it's 4 plus minus 1, which is exactly 3. So you see that, you again see that these two values are the same. The sum of these two suffixes is going to really be the answer, and it's going to be 3. So you calculate the score of the suffixes, you sort them in descending order, and you see that how many you should take so that you reach that sum k. Okay, so I'll also show you code. Yeah, I mean, how to come up with this approach. I mean, you have to solve so many prefix sum problems and double counting problems, and these kind of ideas then are going to be familiar for you. So basically, if you want to know that how to calculate such a thing, I mean, this is experience mostly. I can tell you this is mostly in experience solving so many problems. I personally have solved so many double counting problems and so many prefix sums problems. That's why it comes to my mind very fast when I see such a problem that I can apply double counting and I can apply prefix sums. So if you want to see that how you can reach a level that you can solve these problems fast, I mean, the way is to solve so many problems, like obvious. Yeah, it was a really beautiful question and the solution. Okay, so we can also use priority queue. Yeah, we can either sort an array or use a priority queue. Did you guys enjoy it? If you guys enjoyed the solution, you can use this emoji, for instance. This party emoji. Do you have a girlfriend? Why do you ask? And why do you guess? I can tell you the answer at the end of the stream if you want. But what do you guys think? And more important question is, that's how you came up with this question right now. I mean, in the middle of solving a problem, why this is your question? Please give us some tips on how to practice. As I said in the topic streams, as I told you, we can also have some topic stream on just the guidelines. I also want to make videos for you on guidelines. I will also put them in the in the Telegram channel as well. Let me again share the link of the Telegram channel with you guys. I've shared it so many times, so I guess that by now most of you have joined. But if there's someone who hasn't joined yet, I'll send it again. If you want, you can join there, and let me pin it again. If you want, you can join there, and I'll put a vote on what do you want me to make videos or cover on topic streams. So if you want to lose brain cells, then look for a GF. Yeah, there are different opinions on that. Okay, so it seems like many of you have enjoyed the solution. That's awesome. That's awesome. Okay, now let me show you a code for this solution. Let me find it. One of you have sent a code that you say it's very neat. Let me bring that one. Is Jiangli's solution, or I'm bringing this. So it's loading, as you see. So we should, unfortunately, again, Codeforces is slow. By the time that it's gonna load, I can show you another code. There's a code in Python. After that, I will show this code. This one must probably be in C++, I guess. So I show this other one. Okay, that one was another code. So okay, this one loaded first. So as you can see in here, he or she has calculated the sum of the prefix sums. I see here. So pre of 0 is 2 times. I mean, this 2 times s of 0 minus 1 looks very complicated, but basically it means that if this character was 0 minus 1, if this character was 1 plus 1, that's what it means. And pre of I is equal to pre of I minus 1 plus this. So he has calculated it for all the prefixes, not for the suffixes. You can also do that. Just your calculations will be a bit different in the future. If you calculate the prefixes, because each prefix is a complement of a suffix, now that prefix must have the minimum sum. Because this way, if this one has the minimum sum, its complement is gonna have the maximum sum. So if you calculate the prefixes, now that should have minimum sum. So he sorts all of them, and then he starts from the beginning, and he will each time calculate, compare the next one, and if so far the sum was greater than what he wants, s is equal to m and break. So basically the only difference in this solution is that he has calculated with prefix sums, and he each time take the first prefix sum this way. So basically this is what he's doing. Let me also show you another code. And the fact that you see that he calculates a prefix sum on this prefix sum because he wants to find out the first place that the sum of the prefix sums so far is going to reach some point. So there's also a code in Python by one of my friends, and this is also very interesting. He has calculated all the sums of the suffixes. Suffix of I is equal to this. This line says that 1 if s of I was 1, otherwise minus 1, plus suffix of I plus 1. And he sorts the suffixes, and then he says that was sum, and sum of minus 1 was greater than 0, and sum was less than k. Sum plus equal to sum.pop. So he will take the last one of these suffixes. I mean, he has sorted all of them. So he takes the maximum and adds 1 to ans this way. At the end, if sum was still less than k, you need to print minus 1, because there's no way. Otherwise, you will print ans, the number of ones that you took out. Okay, is it now clear? Oh, and thank you, Akash. Thanks a lot. So you're not supposed to do this, but I really appreciate your support. Thank you very much. It really means a lot. So is it completely clear? Shall we move on to the next problem or not? If you are okay with it and you want to move on to the next problem, problem D, use this emoji or put a plus. And about the next problem, about problem D, I don't have the solution yet. I just before the stream, I quickly read the statement, because as I told you, I just could start reading the statements just before the stream. For ABC, I came up with the question with the solutions instantly, but for D, now we're gonna see the solutions. We're gonna discuss it. I mean, and E and F, I haven't read the statements yet. So should be no more than 1400 for C, probably, or maybe 1400, 1500. How would you solve this question if the amount of points per group was predetermined? Well, that was completely another thing. If they were predetermined, because right now we know that the difference between each two consecutive one is 1. So we say that the suffixes will be multiplied by 1. Otherwise, the sum of the suffixes needed to be multiplied by the difference between the previous group and this group. I mean, it would be a bit different. Anyone know how to do problem D? We're going to talk about problem D now. I got stuck after getting WA on test 2 in my approach. In question C, I should have tried new approach. Yeah, probably. I don't think that problem D would require segment 3. I don't think so. And thank you very much. Is it the same, Akash? That's... Yeah, it seems that you're the same. Thanks a lot. I saw that your name is the same, so thank you. Means a lot. So, yeah. Let's move on to the next one. I will surely do continue the work, and I hope that it would help you guys, and I hope that we can even make it better than what it is right now. Yeah, sure. Yeah, the previous ones are not for beginners mostly. So let's, I mean, the previous ones were with difficulty 1500 and 2000. But I can cover with less. But topic streams topic streams are easier. I mean, I started DP from scratch in topic stream. You can watch the topic streams from here. So if you want, you can watch the previous topic streams from this playlist. And I started DP from the basics, from the beginning, from the very basics. I sent you the link to the topic streams. I extremely urge you to watch those topic streams. Those are the most important things that you need to watch, especially DP topic stream. That's gonna be really helpful for you guys. If you're not familiar with DP a lot, or you feel like you're not good with DP, I really recommend that to reach people. Okay, so let's talk about problem D now. Problem D, let me first bring it. Recommendations. So, this one, suppose you are working in some audio streaming service, the service has end users. First, let me read the statement quickly and see that what is the solution, and then we're gonna talk about it from the beginning again. And it says that J is a predictor for user I if J likes all the tracks that ith user likes. So you say that a song is strongly recommended for user I if the track is not liked by the ith user yet, but it is liked for every predictor for the ith user. Calculate the number of strictly recommended for user I. Okay. So basically, we want to calculate that. This I haven't. This doesn't look like. Let me see that. What are the constraints? I don't see that. What is the challenge yet? I think like I haven't completely understood. Okay, so for each segment, we want to find out what we are looking for is to find out how many segments are there. I mean, for every other segment that completely covers this segment, we want to see that there are how many points are there that they covered in addition to it. It's like we want the union of all the segments that cover these segments. That's basically what we want to do. For each segment, we want to find out the union of all the segments that cover these segments, basically, right? Again, Akash, thank you. And thanks, Char. So, yeah, I also have a LinkedIn account, yeah. You can search my name, Shayan Chashpjan, if you want. So anyway, so it looks like we want the union of all the all of the segments that cover this segment. So let's see that how it has been implemented by others. It says that in this code, it looks like a very short and interesting code. C in LIR, return LIX or RI, LI resistor. Okay, so he sorts all of them by their beginning, by their left side. And if they were the same, by the right one must be greater than the other one. So, okay. So this way, if something covers another thing, it comes sooner than that one. Alright, let's draw a L of O is equal to. It is a very weird way of coding. I mean, he wanted. I'm sure that he wanted to code this in a complicated way, but it's okay. I mean, the good, because it's this shorts in general. In general, is a good code. L of Q of TP. TP is initially -1, so if it was -1, L of Q of TP -1, otherwise L of Q of TP, otherwise -1, okay, Q of U. Okay, so if it was not okay, it just says that if this was empty, it's -1. So it keeps a stack that's for all the segments that cover this segment. Let me check the comments in the meantime as well to make sure that you are yeah, thanks a lot. I'm not sure what are these. Okay, no, I cannot. Okay, so he has kept a stack, and then okay, he pretty sure keeps a stack of which segments cover this segment. Okay. If L of O of I is equal to L of O of I minus 1 and R of O of I is equal to R of O of I minus 1, it's gonna be -1. So basically, if we look at it, but the point is that if some, okay, yeah, now I see, I guess. So we have an order on all of them, and well, basically what we are doing, as it seems, thank you very much, Sharon, as well. It's not very horrible because I mean it's short. I mean I didn't hate that because it was so short, but yeah, I mean it was a bad way of coding. I can maybe read this one as well. So this one also, I think, done the same thing. He has also sorted all the segments, and he has a binary search, and it says that okay, he has a binary search and finds out the last, what is B? Okay, A of B of does R greater than or equal to A of I does R and is equal to mid L equal to mid. Okay. Okay, yeah. So basically, the point is this. Okay, let me explain it to you from the beginning. Love you, Manas, as well. Thank you very much. Thank you, guys. Manas, yeah, you're a very interesting person. The Indian, it's very nice that an Indian person has Azadi Tower in his profile picture. Thank you guys very much. I mean, this really means a lot. Thank you a lot for all your supports. I'm really happy when I see that you guys are enjoying the streams and you really like it. It means a lot. That's what keeps me motivated to continue doing this. Thanks a lot, guys. I really don't know what to say to make up for this kindness that you have for me and this support that you have for me, and it really means a lot. Thanks. So I don't want to keep you waited, so I'm gonna talk about problem D now. From the beginning, I will tell you the solution. Yeah, and you asked that can you do problem F? Yes, I think we can do problem F as well. We can move on. I haven't read that yet, but I think we can come up with the solution together in this. I think so. So I'm not sure. I don't promise, but if you want, you can stay by there, and if you wanted to talk about it, I think we can talk about that. So anyway, let's talk about problem D. Problem D, recommendations. Suppose you are working in some audio streaming service. The service has n active users and 10 to the power of 9 track users can listen to. Users can like tracks, and based on likes, the service should recommend them new tracks. Each user, the user number I, likes a segment from Li to Ri, so each user likes a segment. And we say that user J is a predictor for user I if user J likes all tracks the ith user likes. And then we say that a track is strongly recommended for user I if the track is not liked by the ith user yet, but it is liked for every predictor for ith user. Calculate the number of strongly recommended tracks for each user I. If a user doesn't have any predictors, then print 0 for that user. So, in other words, what this problem is saying, is that for every user, we know that every user is a segment, right? Every user is just a segment. It's just saying that we should consider all the other users that are the predictors of this user. So we should consider all the other users that are predictors of this user. It means that all the other segments that completely cover this segment. Let's use another color for that. All the segments that completely cover this segment. And we need to see that what is their union. Because only in their union, everything that is in their union are the colors that are the songs that are strongly recommended to this user. So basically we need to see that what is the size of this union, and if we subtract the size of this one from the size of this union, we can get the number of songs that will be strongly recommended to this person. Okay. So how can we calculate that? The point is that we can sort all the segments and by their L, for example. I'm first by their L and then by their R. And thank you guys a lot. That means a lot. Thank you very much. Oh, I said union. Sorry. Yeah, I'm sorry. I meant intersection. Yes. I should see the intersection of them. Yeah. I should see the intersection of them and see that what is the size of this intersection, and then from that subtract the size of the segment itself, and then we're gonna have the number of songs that will be recommended to this person. Now the point is that if we sort these songs, the point is that if some song will end, if we sort them by their L, if we sort these songs by their L, the point is that if a song, you know that we have seen all the other songs that their L are less than this. If a song, if some user last song is less than the last song of this user, I can easily eliminate this user because this user is not a predictor for any other future users. Because we sort users by their L. And when I sort them by their L, I know that if from the previous users that I have seen so far, I'm sure that any other users that I have seen so far, their L is less than or equal to the L of this one. But also their R must be greater than or equal to the R of this one as well. So the point in here, again, is that if some user, for some user, is R is less than R of this new user, this one will never be predictor for any future users. So I can just eliminate this user this way. Okay, I can just eliminate this user this way. And it will not be a predictor for any future users. So I can keep a set. In this set, the idea that I have right now, I didn't see in detail that's how others implemented these parts, but what came to my mind right now is that we can keep two sets. In one set, we can keep pair of L and R for each of the users that we still have them, they are not eliminated yet. In one of them, we can keep R and L. So in one of them, we sort them by L first, in the other one, we sort them by their R. So whenever we add another user, we will see this second set and we see the end of it. As long as the last one in that set is R was less than the R of this one, we can keep eliminating that. We can keep removing that. As long as it was less than that, because they are not useful for anyone else. We can keep eliminating that, and do not forget that whenever we eliminate some user J from here, we have to also eliminate the corresponding one in the first set as well. And at the end, the point is that all the sets that remain, all the users that remain in our sets are going to cover this new user. All of them are going to cover this new user. Therefore, it's just enough to see that what is the maximum L between these and what is the minimum R between these. I can easily calculate them in my set as well, and I can just subtract them, and then I have the size of the intersection. And therefore, I'm going to have my answer. So yeah, I'm basically something like similar to, it is some sort of, similar to landscape, because I'm moving forward, and when I'm moving forward, when I see that someone is R is less than my R, it's not going to be useful in future as well. So I'm going to eliminate it. I mean, when it's not going to be useful for this one. I have sorted everything by their left. So I've sorted everything by their left side. So I'm sure that the next one's left is greater than the left one of mine. Okay, there's just something else that I'm also thinking about. What do you guys think about it so far? Have you guys used the same solution or not? Do you have any difference? If you have implemented it and got accept from it? I just want to ensure about something else as well. Are there duplicated ranges in the problem? Yeah, we can have duplicated ranges in the problem, in the sets as well, and also in the problem. Yeah, if you have duplicated, I mean, it's okay. I mean, in our sets we just keep an index as well. So that's not what I mean. And yeah, I think I see what you mean, Shobham. That was exactly the same thing that I was thinking about. The point is that if we eliminate these segments, maybe the next one is gonna have a smaller R. So that's why we need to consider something else. I mean, we need to consider the first R that is greater than my R. We should not completely eliminate them when their R is less than my R. We should not completely eliminate them, because maybe in the next step they're going to be useful. Sorry about that. Wait for a few minutes. I think that these parts should be changed a little bit. And if you have any ideas, you can tell me as well. Yeah, sure. I mean, when I get sure about this part, I will tell you with an example as well. Let me again see this. We have, I'm reading another solution now to see what they did for this part. I mean, my idea is to maybe, I mean, again, using binary search. I was thinking that maybe, I think we can do it also without binary search as well. To be honest, I think that binary search is not needed in this problem. So we can do binary search to find the first R greater than us, and we can also do it from the other side and find the first L before us. This can work. So this is a solution that can work. I mean, if you are following me. If you're not following me, it's okay. I mean, I will tell you another solution. But to fix this, it's just enough that from the segments that I have, maybe let me explain it to you. I mean, the idea that I have. I mean, if I want to fix this, I would say this. If I was in contest and I wanted to fix this, I say that, okay, I have, I can just keep all the elements that their L, I have all the elements that their L are less than me, and I can keep them in a set. Now I can do a binary search and find the first R greater than my R. And I'm sure that these are the ones that cover me completely because their L are less than me, and I'm finding I have a set that I have all of them in a sorted way. I have all of them in a sorted way by their R. So if I do a binary search on that one, for example, I have them in a set, I do a lower bound on that set, I can find the first R that is greater than my R. And I can say that, okay, everything's in here work. Okay, and this way I find everything in here, and once I can do it from the other side and calculate it in the other side. I mean, in the other side, again, this time I sort them by R, go in descending order, and just keep the L's in a set, and I find the first L that is less than or equal to this L, and I will just add this part. So this can work. This is one solution that works. Do you agree with this? Do you agree with this? So this is one solution that it works, but I'm thinking that maybe it is also also possible to do it without a binary search. No, it's not. Binary search on a set is O(log(n). O(log) of size, basically. But I think there's also a better way to do this. A of I that L is equal to... I'm reading this one. Maybe I should show it to you as well. Yeah, basically I think what he does is to calculate these two parts separately. This is similar to what I told you. He has two selves. Yeah, I think that he is basically doing what I told you, and probably he's just not using a binary search. While top and an if was less than A of R, R. The only thing that I'm thinking about is that why they do this while top and an A of stack dot top dot a stack of top dot R was less than A sub I time dot R. Why they're comparing two R's with each other and then they say top minus minus. Oh, yeah. The first idea was right as well. Now I'm thinking. Yeah. I mean, we basically can do this. I mean, the problem that Chopin was mentioning was completely right, but the point is that even though it changed the solution, but it's okay. We can do that. Why we can do that? I mean, the first idea that I told you also works. Even though it is wrong, I mean, the point is that we are removing something. The point is that in that idea, we said that if its R was less than the R of this one, let's remove this. This is not important anymore. But you mentioned that, maybe in future you will see another thing, another segment, that this one covers that one. Well, the point is that if we see such a segment in future, since this one completely covers this one is not going to be important for it anymore. I mean, because this gives a worse answer compared to the previous one. So basically what I'm saying is that if this is this segment if its R is less than the R of this one, the point is that whatever that this one covers, we are not sure that this other one covers as well. This one also covers that one as well, because its L is definitely less than the L of everything that comes next, and also its R is greater than the R of them. So basically, and we only care about the left side now. We only want to find out what is the answer in the left side. So I want that for each segment, I want to find out that in the left side, how many songs can be recommended for this one. Then I say that whenever I see a song, and I see that I had another song that its R was less than the R of this one, I can just simply ignore that song. For example, if I had two songs like this, I can remove this song, because we are sure that this one that comes next, its L is greater than that one, and also whatever that this one covers, this one is going to cover too, and its L is greater than the L of the other one. Its L is greater than the L of the other one. So this one is not really going to be helpful for anything. Even though it covers this one, but it's not gonna make any change on that. So we can really ignore it. So basically what Shobham said is completely right. The point is that it is possible that they will cover something in the future, but they're not useful for it, because this one gives a greater L for them, and for sure anything that this one covers too. So basically we can ignore this one from there. Yeah, so thanks for mentioning that though, and yeah, this is why it can work. Is it clear now? Chemel has sent a solution that is exactly what I meant, or someone else meant. Let me see. Show on right, find mean R, right points, and maximum left points. Yeah. We can find them separately. Yes, finding them separately then it works. Yes, I did same and got accepted. Okay, nice. You can care about the rightmost left so far. Yeah. We only care about the rightmost left so far. Yeah, exactly. Yeah, exactly. We're just care about the left parts, and we care about the right parts later. I mean, we solve it separately for the left side and for the right side. Yeah, I didn't receive any link. You cannot send links, unfortunately. You cannot send links. So maybe you can just send the ID of your submission if you want me to show that, or you can send it in the discussion of the Telegram channel if you want. And by the way, well, the point is that I brought the settings, and block links part is not checked. So URLs will be held. This setting doesn't apply to URLs. Okay, so I guess I should change the default. Probably you should be able to send a link right now. Probably you can test it out. Okay, so are you guys completely okay with it? Shall we move on to the next one? Next problem, problem E. If you guys are ready for that, we can now move on to the next problem, problem. I haven't read problem E as well, so maybe in the meantime that you are responding, I can bring problem E and see that what it says. Let's look at F. It seems easier. I look at that one as well after this. So I mean, there's no difference. I mean, anyway, if we do F, we should do E as well at some point. So probably it's good if we see E first. So you are given a tree, consider and when vertices, recall that the tree is connected and there is a graph with no cycles. Vertex I costs 2 to the power of I. You need to choose a subset of vertices of the tree such that. So you have 2n vertices. Each value from 1 to n is written in exactly 2 vertices. You need to choose a subset such that the subset is connected. Each value from 1 to n is written on at least one vertex in the subset. You need to find the one with the smallest total cost. The total cost must be known. What is the cost? The costs are the values. Vertex I has cost 2 to the power of I. Okay. So let me see. I mean, is this cost based on the indices here or is it based on? Yeah, I think it is. Each vertex has a value and okay. So it's like we want to minimize the maximum and then among them, I think I see what it said. No, channel. It was completely okay. I just meant that I'll do both. So yeah, I am ready, yeah, but I'm not participating in contests for now. I mean, my last contest. I mean, my days of participating in contests actively were a few years ago. I mean, 4 years, 5 years ago. But yeah, I was in IG. Now I'm more into teaching, etc. Let me see what people have done. Let me bring something. I hope that I understood it well. And you're right, Shemal. As I see in here, 36 people have solved E and 97 people have solved F. And the code doesn't look good as well. So I hope that I understood it well. So each value is in 2 places. We want the subset to have all of them, and indices are the order in which they come. For example, the index of this one is 1, the next one is 2, and so on. So if that's the case, that should make sense. That should be okay. Then if that's the statement, which it is, then we're gonna have the edges first, and we start with DFS, calculate the sizes, Size starts from 1, so it's not weighted. Okay, interesting. If n times 2 minus size of u was greater than or equal to n, so if outside had at least n vertices, son of it is equal to father of it. Then for each vertex, starting from the biggest one, we wanted to minimize this. So we try to start from the last one, and we hope to ignore this element and do not pick it in our set when we start from the end. So each start from the end, we erase I. If CNT was 2, then definitely flag is 1. So that is bad, definitely. So in that case, we cannot ignore this. Otherwise, we go from head of I, we go over all the edges. If it was equal to son of I or flag of V. Okay, the point is that if the other side has at least n vertices, the point is that we need at least one vertex. Okay, it makes sense. Okay, this is pointing out to the part that the answer should be in it if we remove this vertex. I'm getting the idea now. So then we will find out that we have another DFS. We'll continue if, okay, I see. There's just one weird thing in here when it is 1. So it just says that if there's any other vertex there, basically flag of I is equal to 1. So if flag is 1, it means that we do not need this, and then we do DFS3. V is equal to father or flag of V, continue DFS3. Okay, I see now. We will remove it so basically we know that when you remove a vertex, the answer must be in one of the components. Only one of the components has the chance to have the answer. So from the other components we have to delete everything. And the point is that you will go and delete them, and you see that if it is still possible to find the answer if you do that. Okay, so let me tell you the solution of this one as well. Let me just see what. Okay, so okay, let's talk about the solution of the next one. Ors Deving Wang has been defeating tourists past 2 contests. Wow. Tourist lost points in the last contest as well. I was thinking that. Yeah. Okay. But he will be back soon, I'm sure. So anyway, let's talk about this problem. Problem E, vertex pairs. It says that you are given a tree consisting of 2 n vertices. Recall that a tree is connected on directed graph with no cycles. Each vertex has an integer from 1 to n written on it. Each value from 1 to n is written on exactly 2 different vertices. Each vertex also has a cost. Vertex I costs 2 to the power of I. You need to choose a subset of vertices of the tree such that the subset is connected, that is from each vertex in the subset. You can go to any vertex, and each value from 1 to n is written on at least one vertex in the subset. Among all such subsets, you need to find the one with the smallest total cost of the vertices in it. The cost on a node is the cost on node number I is 2 to the power of I. So this way, because each vertex number I has cost 2 to the power of I, the point is that when we want to minimize the cost, starting from the end and going backward, we are trying to ignore the vertices as much as we can. So we try to, first we see the last vertex. This vertex has the maximum cost. So we see that if we remove this vertex, if we do not pick this vertex, can we find the subset using the other vertices or not? If we could, we will ignore this vertex. Even if we take all the others, it is better than taking this one. So each time we consider if we ignore this one and assume that we can take any of the others that we want. We have no limits for the others. If we just ignore this one, is it possible to somehow take some of the previous ones to make that subset or not? So what we can say each time is this. When you remove a vertex, since you have 2 n vertices in total, when you consider these components, since the vertices you choose, all of them must be in the same component. All of the vertices you choose must be in the same component. And you know that the subset you choose, its size must be at least n. The size of the subset you choose must be at least n, right? The point is that only one of these components can have size of at least n. The rest will have size less than n. Because if 2 of them have size at least n, we have more than 2 n vertices in total, which is not possible. We know that the number of vertices at most is exactly 2n. So the point is that by removing any vertex, there is only one component. That might have the answer in it. There's only one component with size at least n. So the answer can be only in that one. So we are sure that when we remove this one, we are sure that we never pick these vertices too. So we should only consider if we can take anything in here, if that gives us the best answer or not. It does not give us the answer. So each time we try to see that if we remove this vertex, do not pick this vertex, can we somehow make the subset using the other vertices or not? So then I can say that when I start from the end and I'm coming back, when I ignore a vertex, I just can do some DFSs. I can start from a vertex. When I remove it, I can keep for every vertex. Initially, I can have a pre-process, a DFS in the beginning, and see that what are the sizes of the subtrees, etc. And then find out that for each vertex, which component, the component of which of its neighbors is important and might have the answer if we remove this vertex. So we need the component that its size is at least n. And if there's no such component, we just need to for example, store -1. Which means that this vertex cannot be removed in that case. So I can say, I can keep all this at the beginning, and when I want to remove an element, I just say that. I just run several DFSs. The point is that our n in here is up to 2 times 10 to the 5th. So the point is that each time when you do this, you can just consider this connected component and find out if you have a vertex of each value or not. We need to find out if from each color, each value, we have a vertex of that value or not in here, right? If we didn't have enough of them, then the answer is definitely no. We cannot ignore this vertex, so we have to pick it. So otherwise, if it was possible to somehow use everything that we have in here, then the point is that we can actually ignore this one. So the point is that we have several blocked vertices. We know that these are blocked. So we know that these vertices are removed. We should always, each time it's like we are blocking some parts, and we should see that, okay, in the rest, can we somehow put everything in here to make sure that they are okay or not. And the only point is that how do we do this DFSS? For example, if you look at this code as we were reading it, in here first, initially in our first DFS, we keep the sizes of all the vertices, and we keep that which vertex is the best one. This son of u, if size of any of its children was greater than or equal to n, you keep that vertex as your son. Otherwise, you keep your father as your son. This is the parts that your answer might be in it. And he has stored all the edges like this. He has stored all of the edges that in an array is like a linked list. And basically what he does is this. Whenever he wants to remove something, first he removes that color. And basically in this removing, if the CNT became 2, he will set flag equal to 1. It means that if both of them are removed, it is not possible, definitely. Otherwise, he will just save that what was this vertex that was removed, what was its value, so that he can add 1 to its CNT again at the end, if this didn't work and we wanted to take it back. And then we have a 4 on all the other parts, and we have a 4 on them, and we remove them as well. The first time that we see that we have a vertex that by removing it, we're going to have an issue, we do not continue. So we need to make sure that only in this connected component that we have, we're going to have the answer. And the point is that when you remove a vertex and you are successful of removing it, that's going to be good, because you're not going to remove those parts that you removed before again. The only thing that I'm worrying about is that if you removed some parts and you see that it wasn't successful, so you need to take them back and have a 4 on them again in the future. But the point is that that won't happen as well, I guess. So basically, I mean, the only thing that I'm worrying about right now is the time complexity that we have. I mean, because basically we can have all these DFSs. We can have the DFSs again on the subtrees. That on the other subtrees that we have, the only thing that I'm worrying about is that how the time complexity would work. That's what I'm thinking about right now. But I mean, so far I hope that is it clear so far that what we are trying to do? If it is clear, you can use the 100 emoji or put a plus in the chat. If so far it's clear that's what you want to do. I mean, the first observation was that when you remove a vertex, only the biggest component might have the answer in it. Only the biggest component might have the answer in it. And we keep that one. And the other components must be removed. And it's better to act greedily. And if we can remove something, we will remove that one. And this is how we will move on. So now that we can do some DFSS to find out the answer, the only thing is that in this code that we were seeing right now, that I wanted to understand that how it's gonna work. I'm just worrying about what the time complexity is. I wanted to also check some other codes as well. Let's together watch some other codes and see how others have implemented, and see if it's the same or not. Definitely the idea that the biggest component, the answer must be the biggest component and things like that is the same. But the difference that I see in here is that he has used a sparse table as well. So I'm thinking of how he has used it. If ans of I and 0 is equal to 1 and then ans of I and 1 is equal to 0, okay. Oh. So I guess that ans of I and 0, these are booleans, and if ans of I and 0 is 1, it means that it cannot be 0, I guess. So you said P is 1, but it can still be this. If it is 1, it means that it cannot be that. If it is 0, it still can be that. And at the end, K plus equal to ans of I and P. P is 0. Okay. And he used as LCA. I'm not pretty sure about that, how it's that one working actually, but I'm thinking about maybe this one. I think maybe we can say something about how the time complexity would work this way, because if you add something, if that cannot be deleted, you have to add it. So there are so many vertices, there might be so many other vertices that you can say that these ones must be added as well. So you're gonna be sure about some of the other vertices. If you're not gonna add it, several elements are gonna be removed. So maybe this really, the reason that it got accepted is that it really is, it can be proved that its solution works with the time complexity and its order is not much. So and also you guys, if you wanted to say anything, you can say that as well in here, because that helps to come up with this faster. So yeah, I think that's, for now, I don't think of how the time complexity is working. So maybe probably the thing that we can say so far is only that we have to use these DFSs, and you need to find out that how that can be calculated. And now I'm checking Jiang's code. Has he used HLD really? Has he used heavy lights? It's interesting. It really seems interesting if he has used heavy lights. So he has also calculated the sizes, and And he says this if size, oh, if size of what, okay. I mean, basically, I mean, how it would look at the end. I'm just saying, I mean, because the problem is hard, I mean, it might take a while if we continue this approach, but I'm just saying what comes to my mind. The point is that if we consider the vertices that they will be pointed to, they are the vertices that, for some other vertex, they are gonna be the ones that, they are gonna be the ones that their size is maximum. Or in other words, similar to what Jeremy did, I mean, it's better if we do it like this. We have a DFS, whenever size was less than n, we will return. If the size was greater than or equal to n, we will continue. It's like at the end, we will get a path this way, because from the roots, we can only call one child, and again one child, only one child, only one child. It's like we're gonna have a path at the end this way. And I think probably he will use this path. He uses HLD to try to solve it some. So from the ideas that I saw so far, one of them was using HLD, and he's also, I think, using DSU as well. And one of them was using sparse table. Maybe it was using other ideas as well, but maybe that one also used HLD as well. But this one was very simple. I'm not sure that it's accepted because test cases were weak, or it's because the time complexity can really be proven to be correct. Yeah, I mean, these are the things that I can say for now, and probably I cannot, we cannot continue saying anything else in a very short time. So sorry for that. I hope that the things that the observations that we have seen said so far would be helpful for you guys. Yeah, D is already discussed. You can watch the recap. So, is it okay, guys? I mean, I'm sorry for this. It is not very good that it's happening, but anyway, this is what I can say for now. If you guys also have any idea, you can say that, and I can say it in the stream. But so far, the only things that I'm saying, the only things that I thinking about is that you should consider the biggest connected component, and if you remove this one, only those ones are gonna be good. And you should see that if in there you're gonna have all the labels. For each labels, you can keep that where are them, and one of them must be there at least. Oh, so basically you can consider the LCA of these two. I mean, for each label, maybe this is where LCA can be. I mean, we can consider the path between these two vertices with the same label. And if we consider this path, if the vertex that we're removing is outside of this path, the biggest one must be it's the other one that this path is in it. If it is on the path, there are two possible choices for where they're gonna be. I mean, basically, I'm saying that. I mean, this is the idea that again came to my mind when right now. I mean, for each label, for each color, you can just consider the path between these two vertices with this color. Maybe V is not the best choice. Let's use like C, something like C. And I'm saying that for each vertex that is, for example, in another place, you should consider the subtree that contains this path. And if the vertex is on the path, either this part must be considered or this part must be considered. And maybe you can implement these requirements in a good way. And this way you can find out if you can remove a vertex or you cannot remove a vertex. Well, this way, because definitely for each vertex for all the other vertices, we know that the component that we should point to is the component that has this path. For these ones, we have two choices to find out which one we choose. I think this can be worked on. This definitely can be worked on. If I had time, I would think more about this. Yeah, but sorry for this, that we're not talking about it completely. Shall we move on to problem F as well? Or not? Do you guys want to talk about F as well? Probably on F, again, we do not reach the complete solution. I would be happy if we reach the complete solution, and I will tell you. But if you want, we can talk about it and see what we can say. Maybe we can talk about some observations, and maybe we can talk about the full solution. Depends on how it goes. So I'm going to start talking about the problem F as well. Two subarrays, you are given two integer arrays a and b, both of size n. Let's define the cost of the subarray LR as a sub l plus a sub l plus 1 to a sub r plus bl plus br. The cost is al plus 2 times bl. If they are the same, you have to perform queries of three types. 1px, assign x to it, to a. 2px, assign x to b of v. 3lr, find two non-empty, non-overlapping subarrays within the segment L and R with the maximum total cost, and print their total cost. Two non-empty, non-overlapping subarrays. They should be non-overlapping and non-empty, and they should be completely inside L and R. Okay, let's see what we can say about this one. So, this sounds interesting. I'm looking at the code. Let me bring another one, because this one was not very well implemented. Okay, so basically this problem must be a complicated data structure like segment tree or something like that. The statement is shouting that out basically. But let's see that what is it about. So this code looks like a good code. The point is that he has stored several values. I'm thinking that what these values are. So I guess that you have to choose 4 points. You have 4 important points, right? 4 important. Start of your first segment, end of your first segment, beginning of your second segment, and end of your second segment. So I guess that he's fixing that. What is the range of? I'm guessing that it says that what is the range of these 4 points that we are considering. I guess that probably he means that by this. So for example, 0, 1 is equal a plus b. 0 and 2 is a plus b times 2. 1 and 1 is a. Yeah, I guess that should be related to that, and he keeps that as a matrix. So and how does the combine work? Combine helps us to understand that what is going on. C that a of int is equal to minus n a of int c that a of int a dot a of int plus, yeah, this really looks like it's an interval. what interval is in left, what interval is in right side. Okay, now I think this init is also for one cell. Yeah, init is for one cell. You give A and B to it and it will find out that's what the value is. And whenever you update, you can easily update as well, I guess. You will go to the leaf. When you get to the leaf, you will set it init and then combine back again. Yeah. And the reason that in here we have this is that if we haven't started anything, nothing must be summed up from here. If the first has started but it has not ended yet, so this is the beginning of your segment. Both it will be calculated in A and in B. Because we have started these segments, but we have not ended it yet. If we have started and ended it inside this interval, it's going to be A plus B times 2. If we are just continuing it, it's just A. If it is already started somewhere else and it's ending here, it's A plus B. If it is 2 and 2, it's 0, and so on. Yeah, so yeah, I see what it's saying. Okay, let me tell you the full solution. I think that on this one, I can tell you the full solution. Solving problem topic-wise or rating one, which is better? It depends on what is your state right now, etc. In general, most of times solving rating-wise is better. But yeah, we can talk more about it in the topic streams. So let me tell you the statement of problem F. Problem F, two subarrays. It says that you are given two integer arrays, A and B, both of size n. Let's define the cost of the subarray LR as A sub L plus 2A sub R plus B sub L plus B sub R. And if they are the same, AL plus 2 times BL. And you have to perform queries of three types. 1px, it means that you assign x to A sub p. 2px, it means that assign x to B sub p. 3LR, it says that find two non-empty, non-overlapping subarrays within the segment of L to R with the maximum total cost and print their total cost. So what can we say in this one? Well, basically, we want to use segment tree. And solve some, it's like we're solving DP on a segment tree. I'm saying that for each segment of my array, for each interval in my array, I will solve, DP of I and j in that part says that we know that, basically, first let me tell you this. We know that we have 4 important points. We have 4 important points. The start of our first interval, the end of our first interval, the beginning of our second interval, and the end of our second interval. So we have these 4 important points. So dp of I and j means that if I have the points from I to j in this interval, if I have only the points from I to j, okay, so I'm not solving it for just for having all these 4 points. For any intervals of these points, I will also solve the problem. If I have this interval of my array and I want to put this interval of these important points in them, what is going to be my answer? So first, let's solve it for leaves. If you have only one element. If you have only one element, you can easily solve all the DPs as well. Their DP is, for example, like it's gonna be the number of ranges that you have. It's gonna be at most 4 to 5 squared, for example. Because we have one additional 5 because it can be one additional because it can be empty as well. So I'm saying that this DP of I and j, for example, you can say that this is 5 and this is 5 as well. So the point is that for a single one, for example, assume that I'm calculating DP of 1 and 2, for instance. What does DP of 1 and 2 mean? It means that I have in my important point number 1 is in here, and my important point number 2 is also in here. So this point is both my important point number 1 and my important point number 2. So it's like it's my it's completely my first segment. So I should add a plus 2b from this one. Or for example, if I wanted to calculate dp of, for example, 2 and 3, it means that it is the it is the end of my first one and the beginning of my second one. It should be, because it is both the start of the end of the first one and the beginning of the second one, I think it should be minus inf, because they cannot be overlapping. So in that case, we will put minus inf, I guess. So the point is that we can just calculate it for each range of important points and each range of each interval of our array. I say that if this array is gonna have this range of important points, what is gonna be my answer? And do not forget that, I mean, for example, in this code that I was showing you, in this code that you are seeing in here, in this code, the ranges are open, closed, I mean, inclusive, exclusive. In what I'm explaining here, the ranges are inclusive. So that's why 2 and 3 in here is different than 2 and 3 in here. Okay, so basically, they are going to be different this way. So what I'm saying is that if you look at it this way, you can just find out for each leaf that how much it's going to be contribute. If you have only 1 point, you can see that by just saying that how many of important points, your important points are there, you can see that what is going to be the answer in that part. And then you can easily update your segment as well. You can, whenever you have a segment, you can just say that which points you want to have in the left side and which points you want to have in the right side. And which ones of, I mean, you know that in general you are considering the range of I to j from your important points. So you should find t so that you find from I to t of your important points are to the left, from t plus 1 to j of your important points are to the right. So because you have 5 choices for I and j and t, you can just have 4 on all of them. It's going to be 125 or something like that. And also it's less than that, because I should definitely be less than j and t should be in the middle of them. So it's way less than that. It's like you have just divided by 6 or so. It's like maybe it's similar to, it's not exactly 5 choose 3, because t can be equal to I and j, but it's way even less than 5 cubed. So you can easily merge 2 intervals into one bigger interval, and at the end, I mean, whenever you get an L and R, you can easily find out that what are the answers of all these DPs for that range. And this way you can calculate your answer. Is it clear for you guys or not? If it is clear for you, please put a plus or use the 100 emoji. Otherwise, if it is not, let me know. Does anyone know how many submissions on C are getting hacked? I don't know myself. Are submissions on C getting hacked right now? Have you seen submissions on C to be hacked? Yeah, it seems like some people are being hacked. Nice. What is the rate of C? I think it's like 1500 or so, probably. What would be the rating of DP in topic stream? I started from the very basic in the topic stream. In the topic stream, I started from the very basic. I have 4 topic streams on DP so far, and I think 3 on graph, 3 on number theory, and so on. And soon I'm gonna have the next topic stream as well. You can view all of my topic streams from this playlist. I send them again here. I totally recommend to you to watch them if you're not familiar with graphs, you're not familiar with dynamic programming, with number theory. That would definitely help. Yes. I started from scratch. In the topic stream, I started from scratch. I assume that you don't know anything from DP. That's exactly for you then. If you don't know anything from DP so far, I mean, you have to watch it from the beginning. I start from the beginning and move on to advanced topics. Centered decomposition, next phrase. Yeah, I know that you have said centered decomposition many times. For sure, I will put it in the votes. I will for sure put it in the votes. Hacking means that they find a bug. I mean, your code has got accepted, but there's an issue with your code. Actually, there's an issue with your code, and someone finds that out. That there's an issue with your code, and they give you an input that your code wouldn't work well on that. So your code will fail, and you will lose your accepted verdict. I have got pupil after 2 seconds. Nice. You will get pupil. That's nice. Nice. Okay, guys, that was great. Don't forget to tell me what the topics that you want me to cover on the topic stream. I hope that this live stream helped you. Sorry that on problem E we couldn't come up with the final solution at the end. I hope that this still was helpful for you guys. Thank you very much again for attending the topic stream. Bye-bye.